So let's try a word problem here where we're going to take what we've learned about writing items in standard form and adding and subtracting to combine all into one nice problem here. So what we have is we have the total amount of toy sales in billions consists of two groups: sales of video games, which is V, and sales of traditional toys, which is R. So it's important to know the difference between the two. So we have sales of video games, which is V, and then we have our traditional toys, which is R. In recent years, the sales of traditional toys and total sales can be represented by the following equations. N represents the number of years since 2000. That's very important. So if we're talking about right now, it's currently 2015, N would be a 15 if we're talking about 2015. So what we're going to look at here is we're going to write an expression that represents the sales of video games. So your total number of video games, well, we have a total sales, but your total is equal to your number of video games plus your traditional. So if we need to find an expression for our video games, well, that means what we would do is we would just subtract your number of traditional games from your total. So that would leave us with your total minus your traditional is equal to your number of video games. So what we need to do is we need to take these two expressions and we need to subtract them. So I'm going to start off with a 0.46 n to the third minus 1.85 n squared plus 4.4 n plus 22.6, and I'm going to subtract the expression for my number of traditional games, which would be 0.46 n to the third minus 1.9 n squared plus 3n plus 19. Now, since we are subtracting, what that's going to do is that's going to change the signs of everything that's in our second set of parentheses. So I'm going to change all my signs here. Make that a positive, that a negative, that a negative. And now we can go through and combine like terms. So we have an n to the third, a 0.46 n to the third, and here we have a negative 0.46 n to the third. Those are just going to cancel each other out. Nice. Next thing we're going to add together then would be your negative 1.85 n squared and a 1.9 n squared. So if we take a negative 1.85 plus a 1.9, that's the same thing as having a 1.90 n squared, that's going to give us a 0.05 n squared. So we are now done with those two terms, and I like to mark those out. You don't have to. Then we have a 4.4 n plus a negative 3n. So that's going to, if we subtract those, that will give us a 1.4 n. Then finally you have a 22.6 plus a negative 19. Mark those out, and that gives us a 3.6. This is your expression for the number of video games, sales of video games. So for part B, what we want to do is we want to use this equation right here to predict the number of video game sales in the year 2012. So since n is the number of years since 2000, if we take 2012 minus 2000, that means n is going to be a 12. So what you must do with that 12 is we're going to plug this 12 into our equation where we have our n's. So we're going to say V, whoops, I want a different color. Let's make this green. V is equal to, we use this equation, 0.05 times 12 squared plus 1.4 times 12 plus 3.6. And once you plug that into a calculator, then what you end up getting is V is equal to 27.6 27.6. Now what does that mean? Well, that is your number of sales of videos. So does that mean video games? So does that mean they sold 27.6 video games in the year? No, that is actually in billions of dollars. Woo! So that's a little bit of money that was sold in 2012. So $27.6 billion of video games were sold. So I hope this example helped you see how you can add and subtract polynomials in a real life situation, and then use it to predict the amount of video game sales or any other kind of future value.